and welcome to Traditional Data Techniques and Tools. In this particular video, what we're going to do is start talking about the different techniques and the tools to get the data ready for analysis, okay? And then we're going to talk about where this data comes from and understand some of the tools used. In this particular video, we're going to talk about the traditional data, basically almost data that you guys are probably used to in regards to our curriculum here at Cincinnati State. If we go back to our chart that we've been using, sort of following in regards to trying to understand the whole concept of data science and business intelligence, we're basically going down to the techniques piece here. I'm going to keep following this just for sake of simplicity. I don't want to introduce too many new, variations of this. I just want to be consistent, and I think this chart does, like I said before, a very nice job of concisely telling you exactly what this is all about. So that's what we'll do. So basically what we're going to do is talk about the what techniques are involved a little bit. We're not going to go into grave detail on each one of them, but we're going to explain them, and I'll give you other resources that you can kind of go look at to get a little bit more detail if you would like. All right, so we're pretty much going to focus on this one first, okay, the traditional, right? So we go up here, we're going to focus on the traditional. Our next video will deal with the big data. Then we'll get into business intelligence, and then we'll basically have one all-around predictive analysis, all right, as we kind of walk through the what and so on. All right, and once we get finished with that, we'll also kind of talk about where it comes from. This is pretty vague in a lot of cases, so we'll talk a little bit more about that. And we also will talk a little bit about some of the tools that are used out there. Once again, I won't go into a ton of detail on each one of these tools. We'll briefly talk about them. But then I will also provide you with some resources in which you can kind of go and explore a little bit more of what they are, what they do, and maybe even practicing and playing around with them if you choose to. All right? Anyway, let's get started. When we talk about traditional data, we talk about data. I look at data as a very broad term. It's a very vague term. If I ask what data is in a classroom, I get all kinds of answers. Usually it's processed data or information. But more times than not, I get the word information. I look at data as raw. It's not information. It means nothing. It's not meaningful. It really can't be analyzed too much. Data must be, and so to do anything with it, to make it information, it needs to be processed. So I even look at anything stored within your databases that you've learned about in our courses as raw data. I mean, if you sit back and look at the keys and the IDs and everything else that we have generated from primary keys to foreign keys and so on, some of those tables mean nothing. They are nothing more than keys pointing to other rows of other tables, correct? And so that's raw. We need to be able to take this data and make it more meaningful. And our goal here now is that there's people out there who take this traditional data and get it ready for analysis. It's just not as simple as just taking our database and moving it over. Remember, when we move it over, we basically kind of move a lot of this stuff over to big data, and we utilize this big data environments for processing. And then we also use this traditional data and big data for business intelligence and then predictive analysis through traditional methods and machine learning. Does that make sense? So there are people, I've actually, in preparing for this course and developing this course, talked to many people in the industry, excuse me, that just do this for a living, that do nothing but take traditional data from our traditional databases and possibly other places and basically ready itself for analysis, predictive analysis, analytics, and so on. That's their job. Okay? And so when it comes to getting data ready, we're talking about for a data warehouse. I talked to one person who said her job mainly is that she takes traditional data and converts it and moves it and puts it into a data warehouse for easy accessibility for analytics, business intelligence, and so on. All right? So we must take our data and make sure it's in a form that can be analyzed. So this is a little bit beyond our traditional relational databases. Okay, so what does she do? Well, what she was telling me what she does and what I actually, what most people do in this industry is, when they're doing this piece of it, they get into the data and they cleanse the data. They make sure the data is complete and they make sure it's correct. Now, a lot of our stuff that we've taught you in our database class ensures that also, especially if things are properly normalized and so on. But interesting enough, not everybody in the industry does that. Normalize their databases, ensure all the things are correct and so on. Remember, there's this whole thing about speed. The one purpose of normalization is to maximize our space onto in a database, and because it's going to be faster and more efficient. However, in today's world, when we sit back and look at where it's come the past 10 years, the need to do that for speed purposes and efficiencies kind of is not the same as it once was before, because space is unlimited anymore. We can get space almost for nothing. And speed has really taken off in regards to our cellular networks, our Wi-Fi, our throughput in our networks, and so on. So with that, some people develop databases to make sure they can get to the information as quickly as they can. And that might mean a non-normalized database. It's called NoSQL. You've heard it out, you may have heard of that. With that said, that data needs to be cleansed. It has to be in a way that people, once again, we can analyze it and do it really, and work it well. I hope I'm making sense there. So how we use it on our applications is one thing. How we're going to take this data and use it on our analytics and future analytics and predictive analysis and so on is another. And so we have to take the data we're using in our everyday databases and then make it so we can analyze it efficiently and effectively later on. So it's totally different from applications. This is all around analysis. Make sense? So data cleansing, very simply, if somebody types in the wrong age or wrong birth date, obviously, if you were in my classes, we don't store age too much, but there might be databases out there that do. If it's wrong, it's wrong. If somebody typed in United Kingdom for a name, which is very possible, normalized or not, meaning that that's not a name, that's actually a city, and they basically, or a country in this case, and they put it in the wrong spot. We must fix that kind of stuff, or our analysis will actually be wrong. It's one thing to bring that back. Let's say I go sign up for something on Amazon and I put my first name as United Kingdom. Who cares, right? They're still going to send it to me. My address is correct, and of course, my credit card's correct. But for analysis, that could be a real problem, at least for sake of example. Same thing for age. If I type in the wrong birth date, and based on what I'm doing, as an individual application, maybe it's not that big a deal, but potentially for analysis, it's a huge deal because it's going to skew our numbers in regards to possibly some analysis trying to figure out the average age of our customers or so on. If I'm 932, which there's times when I feel like I am, that might really skew it. Make sense? So these people I've talked about whose jobs are out there in the real world, they would comb this data and make sure it's absolutely correct in regards to this and do what's called data cleansing. They would also look for completeness. If you took our course, obviously, in our database course, we talk about using not nulls. If you have taken our course, we also talk about that not everybody uses that. There is a conflict out there in regards to IT world if you should use not null on your tables or allow for nulls. I'm not here to tell you which one's right. Everybody has their opinions. But with that said, if somebody does not enter something in there, like this age, for instance, that could once again skew our data for analytics. And so data completeness is a real problem when it comes to big data and when it comes to data analysis and so on. It must be there. So these people's jobs are to complete that or possibly remove that record because it does not provide any kind of potential input to our analysis. Does that make sense? That would be their job. Sort of tedious, isn't it? That's what she tells me she does. Data correctness. Once again, I mean, just very simply, we don't check for spelling and so on. Now, we can do things if we normalize our databases for cities and states and so on, but if we don't normalize them for city and states, and sometimes there's an argument about the cities, you can see that very easily we can misspell something from New York to good old Cincinnati, which has been spelled 18,000 different ways, with 2 T's, with 3 N's. I have 4 N's in that one, just trying to make a point here. But if we wanted to do some analysis on people who live in Cincinnati and Cincinnati is spelled incorrectly, and we did not normalize that table, that could cause some inaccuracies and thus hurt us in regards to making our data ready for analysis. All right. The other thing that a lot of these people do is they make sure that the data that we're going to be using is well balanced, okay? And what we mean by that, we want to do it, we make it balanced, and we want to make it representative of the whole. We do deal with statistics on a lot of things we're dealing with here. Not everything when it comes to BI, but from a predictive analysis point of view, statistics plays a big part. We'll get into that a little bit later on in the course. However, we want to make sure that our data is well represented statistically wise. And so that's what we're talking about there. And so when we talk about balance, are there more women than men in the data that we're pulling over? Is that a true representation of the situation? Did we go in this, are there more students over 30 than younger? Now, maybe that's the case, but but the data we're pulling over might not be balanced. Maybe we're just pulling over a few of the records. We need to make sure that it's representative of the whole. For instance, if I'm pulling over a sampling of students from Cincinnati State, and I just go get the first 100 records that kind of show up, right, based on a select statement, is that representing the whole? So these type of people would make sure that happens, that, if our population is 50% women and 50% men, that's the population that would actually come over or be used for analysis. Also, is it random? When we get into statistics, I'm not sure how many of you have taken statistics. Random is the key there. If we're going to do any kind of statistical research, we need to make sure our sampling is random, not predictive, not, what do you want to say, not representing a certain class versus an overall different people and so on, if that makes sense. We'll talk about that, like I said, a little bit later on in the course. We'll actually deal with some statistics because when it comes to BI and data science, statistics plays a big role in this. All right. But to get our data ready, we need to make sure it is representative of the whole, it's random, and it's balanced. All right. So where does this data come from? It comes from all different kinds of sources. It's all based upon what the company uses right now and so on from a traditional point of view. Obviously, it probably comes from like consumer data, for an example, student databases, for example. From a traditional side, it comes from there, but it could also come to non-relational databases, as we kind of spoke of before. It could come from Excel spreadsheets. It could come from anything that maybe the company even uses on a daily basis externally to actually get to do their jobs every day, but they want to utilize to help them analyze where they are today and where they're going into the future. So there's no one answer there. Obviously, the traditional databases that you're used to from our curriculum to 10 times more based upon what a company actually uses. Maybe some of you have already co-opting and seen some of this kind of stuff in regards to what companies are using when it comes to data science. All right, the tools that are used today. There are many tools that professionals use to do this work, and this is not an exhaustive list. Matter of fact, if I went out and asked people, which I did, there's probably different tools that are on this list. But from a programming point of view, Python has gotten huge in the industry. Python's gotten huge in just about everything. So there's a whole piece of Python for analysis and resources. Under the resources, I provide you some information and some links that you can go to get a little bit more information about it. R is a language specifically used for data analysis and data analytics. It was created for that. Once again, you see that asterisk next to there. You can go, I gave you some more resources to go look about what it is, how it works, where it comes from, and you can even play around with it if you like. SQL, obviously SQL is a huge language to do exactly what we're doing right now. And so I know the majority of you, if not all of you, hopefully know SQL by this point in time. That power is a big part of the data analysis, and it's used not only in this traditional method, but you'll see later on in BI and even in predictive analysis, SQL comes into play. MATLAB's another product that you'll see out there used on a daily basis. Once again, it's another programming tool, third-party programming tool, has a nice platform to it. It's really focused on data analysis, data analytics, and so on. And once again, I provide you more information under resources for this particular week where this video is located, so you can do a little bit more research on what it is and so on. And I recommend that you do that. All right, other pieces. Let's see here. think I was a copy. The other third-party software can be used. And there's third-party software out there beyond developing your own stuff. Excel, obviously. Excel is a very not only does it just do a spreadsheet, but there's so many formulas and interactive formulas that you can use with Excel to actually extract data and do some wonderful analysis on your own, especially if you're really, really good at Excel. And there's functions and so on that's all part of that. IBM SPSS is a statistical package. It's used for quantitative research quite a bit, basically using data. Used it quite a bit in my PhD work in regards to doing quantitative research based upon a research project and going out and using numbers and then taking them through statistical formulas to actually, prove or disprove a theory, all right, or hypothesis. And so IBM SPSS is a very nice tool for that. It's been around a long time, and it works quite easily. You don't have to be a brain in statistics to use it, but you need to understand maybe what the results of it mean. But that's pretty much what IBM SPSS is all about. Once again, I gave you more information out on resources to do a little bit more investigation on what that tool actually is. It's been around a long time. It's probably being replaced a little bit with certain things. Tableau, something we'll play around with later on in this course, is one, and so on. All right? Okay, that's it. So, like I said, I wanted to just take an opportunity to walk through this. We don't need, the goal of this course is kind of high level, but hopefully it's giving you enough detail that you're completely understanding what each piece is doing, how they all relate to each other, and so on. But we'll talk about the next video. Then what we'll do is we'll talk about what the techniques are dealing with big data. All right, we'll see you then.